Hi, welcome back to math. We're going to continue on with learning our factors, but before we do, I want to teach a little bit about the distributive property. It's another property. We learned about the commutative property. We learned about the identity property of multiplying by 1 and the zero property. The distributive property will be useful as we continue learning our factors. And distribute just means to separate, move around, divide up, and that's exactly what we're going to do with this. So let's learn about the distributive property. Bob, take it away.
How can you break up a multiplication fact? Maria wants to set up 7 rows of 4 chairs for a meeting. She wants to know how many chairs are needed, but does not know the product of 7 times 4. You can use known facts to help find the product of unknown facts. How does this arrangement of chairs show 7 times 4? The chairs are in an array. There are 7 rows with 4 chairs in each row. How can splitting an array help you multiply? Think about this question as you do the activity that comes next. Maria thinks of 7 rows of 4 chairs as 5 rows of 4 chairs and another 2 rows of 4 chairs. Could Maria have broken the 7 rows any other way? Yes, she could have broken the 7 rows into 3 rows of 4 chairs and 4 rows of 4 chairs. The distributive property says that a multiplication fact can be broken apart into the sum of 2 other facts. What is 5 times 4? What is 2 times 4? 5 times 4 is 20, and 2 times 4 is 8. 20 plus 8 is another way to find 7 times 4. So 7 times 4 equals 28. Would the total number of chairs have been different if Maria broke up the 7 rows in a different way? No, the facts would have been different, but the total number of chairs would be the same. Maria needs 28 chairs in all.
All right, so distributive property. This can get a little tricky. The way Bob explained it there, if you think about the chairs, basically what they're saying is if you have a group, an array, it doesn't matter how you break it apart, you're still going to have the same number of chairs. So hopefully that can help you out a little bit. I want to look at page 109, and I just want to look at this array and kind of explain what Bob was explaining too. If we have this group, on this side it's 1, 2, 3, 4, 5, and across it is 4. Okay? That's going back to when we were talking about arrays back in the day. We can take this and break it apart into different groups. So let's say I want to break it here. Now instead of 5, I have 2, and then here I have 3 in this group. Still 4 across the top. So now I have 3 groups of 4, and I have 2 groups of 4. So that is 3 groups of 4, and I'm going to put those in parentheses to show that those go together. And I also have the 2 groups of 4. And maybe that can help me to solve this. Another way I could break it apart is, let's say we have just one group. So now I have one group of 4, and I have this big group, 4 groups of 4. So I would say that is, and I'm going to put it in parentheses, 4 groups of 4 and this one group of 4. It's the same number of chairs. I'm just breaking these groups apart. 4 groups of 4 is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And one group of 4, anything times 1 is the same number. And so that's going to give us 20. And when we had it all together, it was 5 groups of 4 and 5 groups of 4 is also 20. We don't change the number of chairs. We just change basically how we're counting those chairs, how we're figuring out how many chairs we have. And we're going to use this idea to help you with the factors that are coming up from multiplication. Let's turn the page to page 110. And here you see the chairs that Bob was just talking about. And you can break these chairs into whatever groups you want to break them in. You're just counting. So let's say I'm going to break, because we've got 1, 2, 3, 4, 5, 6, 7 chairs on the side, and 1, 2, 3, 4 across the top. And I want to break these into different groups. I'm going to take these chairs and count them. So that's 2 rows of 4. And then I'm going to take all these chairs and count them. So that's 5 rows of 4. So now I can say, well, I've got 5 groups of 4, and I have these 2 groups of 4. And 5 groups of 4 is 20. And 2 groups of 4 is 8. And that's going to equal 28. So it's just a way to break down large groups into 2 or 3 smaller groups to help you figure that out. All right, let's look at this. What are 2 ways that Maria could break up the array? Well, we already did some of that, so I'm not even going to worry about that. Let's go over here to the do you understand? Do you? Raphael broke up an array for 6 times 3 in 2 new arrays. Both of his new arrays are the same. What were the 2 arrays? So in other words, he had 2 arrays that when he split this, 6, he ended up with the same. So I'm going to draw that. 1, 2, 3, 4, 5, 6. And there's 3 in each one. Keep them nice and straight. And he broke this into 2 arrays that were the same. So, in other words, he broke it into this group and this group, because those have the same numbers. And this is 3 groups of 3 and 3 groups of 3. He took this number 6 and broke it into a 3 and a 3. He took this 6 and broke it into 3 and 3, because 3 plus 3 is 6. And broke up a large array into 2 smaller arrays. The 2 smaller arrays show 1 group of 8 and 4 groups of 8. What was the larger array? Now you can't break both numbers. You can't, here we didn't break it into this and break it into this, because then we're getting into all kinds of complicated stuff. So she had rows of 8, or 8 columns, and she made it into 1 with 8 and 4 with 8. So all we got to do is put these numbers back together, making it 5 groups of 8. All right, hopefully you're still with me here. Let's look at this. Do you know? In 3 and 4, use the smaller arrays and the distributive property to find each missing factor. Fancy words. Remember, factors are the 2 numbers you multiply together to get the product or get the answer. So they took this array that had 4, and you can see they left a space and they broke it right here. So now on the bottom, instead of having 4 on the side, we have 2, but we still have 8 going across. And up here we have 2, and we still have 8 going across. So it would be 4 times 8 is the same as 2 groups of 8 plus another 2 groups of 8. They don't even want you to find the answer here. They just want you to work on breaking them apart, distributive property. Here we had the group of 3 rows of 5, and they broke it into 1 row of 5 and 2 rows of 5. So down here to fill this in, we take this problem. 3 groups of 5 is the same as 1 group of 5, oops, we already had the 1. 2 groups of 5 plus 1 more group of 5. Distributive property. I want to jump down here and do these 2 also. Number 5, 4 groups of 5, which is what we have right here. It says separate the rows in the large array into 2 smaller arrays. You can do it however you want. I'm going to break this one right here. And now I have 2 groups of 5 and 2 more groups of 5. So 4 times 5, or 4 groups of 5, is the same as 2 groups of 5 plus 2 more groups of 5. Think about this equal sign. I keep saying is the same as. Equal means is the same as. And if you'll read your math problems like that, it might help clarify a little bit. Let's go to this big one. I'm going to break it, how about here? So now I have 2 groups of 6 and 3 groups of 6. So 5 groups of 6 is the same as 3 groups of 6 plus the other 2 groups of 6. All right, distributive property. We're going to be using that to help you with the upcoming factors that we're going to be multiplying by, with 3s and 4s, some 7s and things like that. Some of the bigger numbers that are a little bit more difficult.